Okay, so now this one, we're going to continue on with our graphing our inequality because there's several questions and then we're going to get to the corner points. So let me pull back what we had and get the right thing here. So here's where we ended our last video, right? Now the question is saying the solution region is, and when you pull down your answers, you have two answers, bounded or unbounded. All that means is once you know that your solution set or your region is correct, you can see that this yellow has a boundary, right? It's not going anywhere. So it has a boundary. So this would be considered a bounded inequality, okay, or bounded system of equations. If it was unbounded, let me show you what it would look like. If I had a graph, and let's say I had a couple lines, you know, here and another line here, and let's say that my shading overlapped out here. Okay, it overlapped out here. Well, you can see this is going on and on and on forever. So that would be considered unbounded. That's how you know the difference. All right. Unbounded means there's no boundaries. It's not being blocked in, if you will. Okay. It's all locked in on this problem that we just did, where the yellow feasible region is. Where this one down here, it's just going on and on and on and on and on forever. Okay. So that's the difference between the two. Okay. So I'm going to do a final check. They only give you one choice on this one. Okay. So now what are the coordinates of each corner point? Okay, so as I said, the corner points, so this is the new part of 5.2. The corner points is where we're going to look at our feasible region and we're going to see, so remember our, oh man, now I got to remember what colors I used. The orange one was here. I forgot my colors. The green one was the middle, and that was this one. And the purple one was this one. Okay, so this is what we have to look for. Which lines are crossing, right? So I have a corner point here. I have a corner point here. I have a corner point here. Where the lines cross is here. So this one, that crossing is my orange and my green. Okay, so remember we had green was in the middle, orange was at the bottom, and purple was the first one. Okay, so this first point here is where the orange and the green line intersect. Okay, so what I'm going to do is I am going to come over here and I'm going to rewrite those without the inequality. Okay, I don't need the inequality anymore. Oops, I did the wrong color. Okay, so the orange one, oh, come on, pick up the right tool, is x plus 2y equals 20. And the green one is x plus y equals 11. This is where 4.1 comes in. Remember, you are finding the system of equations. Okay, so system of equations means we're going to do elimination, right? So I'm going to multiply the top through by a negative, and I get negative x minus 2y equals a negative 20. And now I'm going to add. The x's are eliminated. I end up with negative y equals negative 9. And so when I divide both sides by -1, I get y equals 9. Now, it should match your graph. You see how this is above, right in between the 8 and the 10? So we're good. So then once I get my y, now I'm going to go back and I'm going to plug it into either equation. I always pick the easier one, and I get x equals 2. Well, look, here's my x is 2. Here's my y is 9. That's right where that corner point is. Okay, so the first corner point is going to be 2, 9. Okay, now I'm going to do the same thing. So I have the purple line. So this corner point right here is the purple and the green. The purple and the green. So the purple, I'm going to have to move over here. The purple was 2x plus y equals 16. The green was x plus y equals 11. Okay, now I need to eliminate. So I'm going to multiply. It doesn't matter which one I do. I'm going to multiply by negative on the bottom. So I end up with negative x minus y equals negative 11. When I add these two, I'm going to go 2x minus x is x. The y's cancel. And 16 minus 11 is 5. So I have a point at 5. So let's look. Does it match? So here's 4, here's 6. The x value is right in between. So we know we're good. We know we did it correctly. Okay, now I'm going to plug it back in. So I have 5 plus y equals 11. Oops, I don't know, because I'm thinking of what the answer is. So y equals 6. And again, if my x is 5 right here and my y is 6, it matches. So that is my another corner point. Okay, the other corner points are 0, 0, and then my x-intercept of 8, 0, and this y-intercept of 0, what was that, 10, I believe, 0, 10. Okay, so all these are corner points. All right, now when you are entering your answer, notice what it says. Type an ordered pair, use a comma to separate the answers as needed. So you're going to do all of these ordered pairs. So look, you can, here's your ordered pair right down here. Here's one. I'm going to put in my values, and it doesn't matter what order you do it in. Oops. Get rid of one of these. Okay, here's one. Now I can do comma, put in another ordered pair. 8, 0, comma, put in another ordered pair. 0, 10, comma, put in another ordered pair. 5 and 6. Notice I'm putting the comma on the outside. That's what it asked me to do. And then 2 and 9. Okay, so I have 0, 0, 8, 0, 0, 10, 2, 9, and 5, 6. Those are all the corner points. And I can always double check. I have 1, 2, 3, 4, 5 corner points. I have 1, 2, 3, 4, 5 corner points. Okay, so that's how you're going to find the corner points. You have to keep track of which line is which, where the lines cross. So you have to keep track which two lines are crossing. Whichever two lines are crossing, those are the two equations that you're going to use to do elimination to find out exactly what those points are. Okay, I'm going to stop there.